All right, welcome back. So today we're going to be talking about 3.2 in your textbook. This is the Big Ideas Blue math textbook. And it's all about the angles of triangles. And we're not talking about just the three interior angles. We're going to be talking about what are called exterior angles as well. So today, by watching a visual and algebraic demonstration, I will discover, explain, and apply a rule that relates a triangle's interior and exterior angles in order to solve for a missing angle. So our goal is we want to be able to solve a problem that's going to look like this picture here. But before we do that, we have to establish some definitions, some terms, and some pictures for us to help understand the differences between the angles. So in this chart, we're going to break down three different key terms. We're going to break down interior angles, exterior angles, and what we call remote interior angles. And I'm going to try and help explain it as best as I can. So for interior angles, the definition is that it's just the angles inside of a polygon, right? So if we're talking about the interior angles of a triangle, it would look something like this, where those three red arcs signify the angles inside of the triangle. If we're talking about exterior angles, well, exterior means outside. So it's going to be the angles outside a polygon when a side is extended past the vertex. And you're probably thinking, well, what do you mean extended past the vertex? So it would look something like this. Notice how we have a triangle, and it seems to have little branches coming off of it, where it's not just a triangle, it has extensions. So these green angles are going to be what we call the exterior angles. It's the angles that don't necessarily make up the triangle. It's what happens on the outside of the triangle, hence the word exterior. For the interior angles, it's the angles inside, so the angles that make up the triangle. For the exterior angles, it's the ones that are outside the polygon that don't necessarily create that polygon inside. It's just the ones that are outside if we continue to line. And now we want to talk about remote interior angles. So the definition says the interior angles that are not adjacent to the exterior angles. And adjacent means next to, right? So let's just jot that down. Next to. So adjacent means next to, right? So we're talking about the angles of inside the triangle that are not next to an exterior angle. So what that would look like is something like this, where we have this blue angle on the right. And notice how that's an exterior angle. That blue angle is an exterior. Okay, well, the remote interior angles are the ones that are opposite from it, are not touching it. Notice that this angle right here touches it. So this part right here is touching that blue angle. So we don't want to include that. We're going to include the ones that are not touching it. So those are what we call the remote interior angles. And a good way that I heard that might be able to help you remember the remote interior angles is when you think of remote, you might think of a television. So if you want to change the channels that you're away from the TV, well, you use a remote, right? So if you're not next to the TV, you can't change the channels unless you have a remote to actually do that. So hopefully that helps, but let's talk about some more applications of these three types of angles. So we have interior angles of a triangle add up to some degree, right? This is actually going to be 180 degrees. The interior angles of a triangle will always add up to 180 degrees. And I want to show you a quick visual for this. So let's say I have a line, right? We know that a line is 180 degrees. Well, what if, and just bear with me, what if I took these three angles, the blue, the red, and the green, and I went, hi-ya! I just chopped them up, right? So I went, foom. I went, foom. I went, foom, right? So now I cut off the corners of a triangle, and you can do this at home. Take any piece of paper, create a triangle, and then cut the corners, and you are going to see something remarkable happens. what if I turn them a certain way? You know what? Order, bring to front. If I can get it to line up, there we go. Order, bring to front. And I'm going to try and match up all of these vertices of these corners. So you notice how these angles are starting to touch each other. Bring to front. And if I turn this in a certain way, boom, look at that. So you see that these three angles make a straight line. And we know a straight line is 180 degrees. So again, this works for any triangle. If you take a piece of paper, create a triangle, and then cut off the corners, you are going to see that it will always add up to 180 degrees. So again, the interior angles of a triangle add up to 180 degrees. Sweet, 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 sweet. Let's keep it going. Smiley face. All right. So let's talk about an example how we would use the application of interior angles being 180 degrees. So I want you to try and set up an equation that could help you find the value of x and then resume when you want to hear us go through it together. So if you did it on your own, that's awesome. If you want to check your answers, that's great. If you were confused and you're like, I don't really know where to start, that's totally fine. So we know we have a triangle and we have three different angles that create the triangle. Well, using our knowledge of interior angles, we can set up an equation. Well, this x right here is this angle. This 42 is this angle. This x minus 38 is going to be this angle right here. Notice how we added all three angles together, and we know that the interior angles add up to 180 degrees, so we set it equal to 180, and now we just have a multi-step equation, which you've mastered. So we can combine our like terms. X and x is 2x. Positive 42 minus 38 is 4. And that's still equal to 180. We want to get x all by itself, so we want to subtract 4 on both sides. Now we want to get x all by itself, so we divide by 2 on both sides. So we get that x is going to be equal to 88 degrees. Oh, and what did I forget to do? Box in that answer. There we go. Sweet. All right, awesome. Let's keep it rolling, folks. So we want to talk about exterior angles now. We talked about interior, and now we want to talk about exterior. So exterior angles are a little bit different. So notice how on the inside I have the same triangle we had before. It had the blue, the red, and the green angles, right? And we took them apart and we manipulated it in such a way that we found they equal to 180, which is great. So notice from each vertex of that interior triangle, we have a line coming out of it, right? And there are angle colors drawn there to show you there's a difference between it. So up here, you have an interior angle that's blue, and what we call the exterior angle, that's that like peach-like color. Down here, we have an interior angle that's red, and an exterior angle that's more of an orange, right? Remember, the exterior angle is on the outside of the triangle, and then down here, we have an interior angle that's green and an exterior angle that's purple. So what we're going to do is we're going to answer the question, and then we're going to show why it is. So an exterior angle of a triangle is equal to the sum of the two remote interior angles. And here's what I mean by that. Let's say I, again, drew a line, right? And I wanted to create a corner. So notice how I'm creating or just highlighting our purple exterior angle. Well, we need to find the two remote interior angles. Well, it's not going to be that green angle because the green angle is attached to the purple. So that's not remote. The blue angle and this red angle are going to be the remote angles. And if I line them up in a certain way, let me bring to front. If I line it up in such a way, you can tell that something cool is about to happen. Look at that. Okay, we brought the two remote interior angles together, and notice how it fits perfectly on that exterior angle. And now you're probably thinking, oh, right, cool, like it only works for that one. Well, we can try it again, and we can do it for any exterior angle that we want to. See, that goes right there. So let's say that we don't want to use this one. Let's say we want to work with this peach-like one, right? Let's say we want to work with this exterior angle right here. So we need to find the two remote interior angles. Well, it's not going to be that blue angle because that's touching it. We're going to need to use that red and green. Let me send the green to the front real quick. And now let's see if we can do it. So that green falls along there. I'm going to turn this, that way our vertices are touching. And notice how when they touch, it's right on the line. And given that this line isn't, perfect, but notice how it still forms that exterior angle, right? So the exterior angle is the sum of the two remote interior angles. If you want a more quote-unquote formal way to do it, if you know that a line, say this line right here, we know that that's 180 degrees, right? We know that a straight line is 180 degrees. So this is composed of the purple and the green, right? If I bring this green back down to where it is, right? It's composed of the purple and the green. Well, if we want to take away this green angle, right? If we take it away, then we're only left with a purple angle. And if this explanation is confusing you, just skip it. It's fine. But if we only deal with this purple angle, right? We know that this is 180 minus the green, right? So 180 minus the green. Well, if we look at a triangle, up here, a triangle is 180 degrees. What happens if I take out this green angle from it? Well, I now get 180 minus the green, and that's equal to our red and blue. So if we know that our red plus our blue angle, so our red plus our blue angles is equal to 180 take away the green, and we know that this purple angle is equal to 180 take away the green, then we know that our red plus our blue is equal to purple. And I believe that works in the color wheel too. Sweet, right? So that's another way to show that the two remote interior angles add up to the exterior angle. So we have this setup here, which is where we wanted to end on it, right? We wanted to be able to set up an equation, that way we can solve for x. So in the example on the left, try it out and then resume when you're ready to see how we do it. All right, so on the left-hand side, we have an exterior angle of x, and then the two remote interior angles of 40 and 45. So it's just going to be x is equal to 45 plus 40, which is 85. Okay. On the right-hand side, it's a little bit more complicated, but it's the same general concept. You have an exterior angle of 125 and the two remote of x plus 5 and 95. So we're going to set it up as 125, our exterior, is equal to the two remote interiors, 95, and x plus 5. And then we are just going to solve from there. So we combined our like terms. We get 95 plus 5 is 100. We subtract 100 on both sides, and we get 25. And that's how we use exterior angles to help find the value of x, as well as how to apply the information of interior angles to help us find the exterior angles. And I hope this video helps. If you have questions, please reach out. I'm uber proud of you. Keep up the great work, folks. Miss you. Have a good one.